There we go. So what we're talking about is once you've taken your diagnostics test in ALEX, you will have this pie, and it will say how many topics you've completed, how many you have left to learn. So there's this mastery thing, and then there's this learn thing. Your job is to complete all of them by the end of the semester. So what is that? 165. So a person who starts at 91 is like about halfway through. So you're way ahead of the game. And then if you look at how kind of the due dates are organized, there's topics that are grouped by lesson that you kind of move through more or less linearly, but you can also kind of jump around a little bit, and then you can end up getting ahead. So these are pretty clearly unit or lesson 1-1 topics. Can you jump around? One of the things that won't let you do topics in later units unless you've completed like the prerequisite knowledge. So for example, if I look at this, what let me do, this is locked word problem involving a US customary length conversion because I need to learn something else before I can get to this. So there's that. I don't know if that does that help?
Yes, thank you.
Okay, you are welcome. How did you all do? So first I should apologize for I disappeared over the weekend. I had lots going on, and I didn't respond to any emails. I had a solid like 50 emails to respond to. It was fun, and I did that on Tuesday. So a bunch of you got responses that were way too late. One thing I did is I moved the due dates for everything from week 1 to this coming Sunday, 9/11. And then week 2, I left all those due dates for 9/11. So we'll just like see where things fall. I just want to make sure everyone's clear on the lesson checks because I've had a few questions on it. These lesson checks are questions directly from the textbook. Let's see. Where are you, friend? Here we go. So for example, this first question said, enter the answer to question 4 on page 11. Now, I have been back and forth with the Biblio people, and apparently they don't do a textbook anymore. So if you are not purchasing the printed textbook, which I actually encourage you to do, but you don't have to, the ebook is found by going into ALEX, and then these little triple lines on the top left, there's a textbook option right here. Click that, and there's the ebook. Turns out McGraw-Hill will sell you a loose leaf version of this for $27. It's $36 at the bookstore. They do have a little bit of a markup. They said 20%. Is that really what that markup is? That's a little bit higher. That's okay. I don't know if McGraw-Hill charges you shipping, but so you can get a print book there. Otherwise, you've got this ebook in here. It's a little wonky to read through because they don't really, it's not formatted like a book where it turns pages like Biblio's books typically are. They've got the page numbers listed here, and then you just kind of scroll through it. So today we are doing, we're doing unit 1, lesson 2 and 1-3. Boy, that's a pain. And apparently I'm not knowing how to click there. So here we go. I think if we go here, yes. So here I am on the unit 1, importance of being numerate. Notice that's the actual page number that's going to correspond to the page in the lesson check. And then page 4 for that one problem, or what page? No, it's question 4 on page 11. So here we are on page 5. Now watch as I scroll. This is kind of ridiculous. Here's page 6, just like randomly smashed in this long page of unit 1-1. And the question you had to answer, page 9, page 10, page 11 is right here. So the question was this one. And just in case you don't know the answer, to calculate a percent of, you convert that percentage to a decimal, which is take the number and divide it by 100. So 0.2, and then multiply it times 79. This is the answer to the lesson check, $15.80. And I think, where are you, friend? I think that I'm trying to make sure I do all of the lesson checks on the videos so that everyone gets 100% on that. I've also changed it so that there are unlimited attempts. So if you put it in incorrectly, accidentally or whatever, you can go back and fix it until you get it right. Any questions on that mess? Okay. What was the other thing? Oh, so then the other assignments you're doing, the homework stuff, are the worksheets. So these worksheets are here. So there has been no due date that's passed for anyone. So if this is your first day here, welcome. And your first due date is September 11th for everyone. So these worksheets, I have them set that they need to be submitted as a PDF. One of my colleagues linked all of these for me, so you could get the digital version here. Just click it and it opens, I think. You're not going to be able to write on this view. If you're wanting to do this digitally, you're going to have to download it. So there's this download button. And then if you have Microsoft Edge on your computer, that's a pretty handy way to write because there's these draw tools. And I have this nice pen and thing, like I think I've shown you all. And like, so the answer for this first one, it's a number divided by 100. That is a reasonable definition. If you have the paper version, which I also encourage, you can purchase it from the bookstore for like $4. You can then use your phone. If you have an iPhone, there's the Notes app that will scan the page and turn it into a PDF, and then you send it to yourself. Or the other two apps that I know of is Genius Scan and Cam Scanner. They're both free, like with ads or something, or they put a stamp on it, so you don't have to pay for those, but they will scan the app and save it as a PDF, and then you can email it and upload it. Does anyone need to see how to upload things? Let's just do it anyways. Even if,
would you mind going over it again? I thought I did it with my one assignment, but I don't know if there was a confirmation that I missed it. When I went back to check on it, it wasn't there.
okay, so let's see if we can make it happen. Okay, so when you go to submit, this is exactly what it'll look like. And Canvas can be a little weird because there's like this top bar, and then notice as I'm scrolling, like in the submission part, there's this scrolling spot here. It's a different scroll area than like the whole page. So that's a little weird. To submit things, you can click this and it'll open up folders. You can also drag files into here. So I'm just going to click it, and I don't know, what am I going to submit here? One of the issues is you have to know where you saved your file. So it might be helpful to like find a place where you're always saving things. I think there's a PDF in here. Since you're only allowed to submit PDFs, only PDFs will show up here to be submitted. So I'm going to submit this to myself and see what happens. Oh, so then you click the submit assignment. Oh, Oh, that's fun. Apparently you'll get confetti and then it should show up. That's strange. So Maya, did that not happen for you?
That's so weird because I did get the confetti, but when I went back to the assignment, it said not submitted.
Oh, what is this bar?
So
Okay,
I can attempt to do it again, but I promise I'm doing my homework.
oh, you're remember soft deadlines here anyways, so you're fine. I can I'll look on my end to see what I can see. Apparently, if you submitted a PDF, it will show up here so you can see what you submitted. I've also seen in my morning class there was like a line up here that stated what the file was, but I'm not seeing that this time for this one. So I don't know. You can submit multiple times, like infinite amount of times actually. I'm going to try to get some grading done between, what is today, Wednesday? Yes, between now and Monday of next week. So you should start seeing some grades populate in there. One thing about Alex is it's its own separate like software system. So you won't see any grade in Alex. And if you do, it's meaningless. I'm going to take, the only thing that's coming from Alex is the number of objectives or whatever they're called that you've completed out of 165. And that will be put into Canvas at some point. Other questions you'll have? Okay.
I have a question.
Yeah, go ahead.
How much of our grade is going to be based on whether we're right or wrong on questions?
Excellent
On the homework.
100% of the grade. Yes, so I grade for correctness. So for this first worksheet, I would grade all these problems, and apparently it's 20 points. That doesn't seem right. I'll probably do something like 2 points, 2 points, 2 points, 2 points, 2 points. Yeah, 4 points. How's that feel? So 4, 6, 8, 10, 12, 14. This one should really only be 1 point. 13. Okay, so there's 13 points possible. And so if you get them all right, you'd have a 13 out of 13. I think we will have attempted most of these problems in class. So I'm, as long as you've been able to either view the videos and check the work you've done, or we're here and we're part of it, you should have 100%. I'm expecting these worksheets to be 100%. And typically how we would start class is, hey, does anyone have any questions? And someone says, can we please do number 3 on the worksheet? And we would do it. So I don't know if that helps you feel better or worse, but.
Yeah, that definitely helps. I know I've gotten quite a few wrong on either one of them.
So if you want to redo them, by all means, redo them. Don't forget, oh, that's the other thing I forgot to say. At the top of the page now, I created this module at some point this weekend with all the Zoom links. And so there's our class session link. I guess I should say what time this is, shouldn't I? What is this? 1 p.m. To 2:50, or is it 3? I think it's 3. So that's there for getting here. Here's the tutoring hours link. I should have stated the dates, the times on this. This is Monday through Thursday. Virtually, it's available 8:30 to 11. So in the morning. So just pop in, click that link between 8:30 and 11, and I should be there. Today was not, I wasn't there, but I didn't look like anyone showed up. So it was okay that I wasn't there. Also, Tuesdays and Thursdays, I'm on campus in my office if you want to come in person. and whether don't like the whole Zoom thing. And then the recorded sessions link here takes you to this YouTube channel where hopefully I will be dumping, well, I'll be uploading as quickly as possible the recordings from the previous class sessions, and there's the crazy me. And they should, boy, it looks like I need to upload some more. I didn't upload everything, but they should all be here. Great questions. Now that we've done all that, is there any questions we need to go over? Anything that anyone wants to look at before we dive into today's work?
I have a question from 1.2.
Yeah.
The degrees of the pie chart. I don't know exactly how to calculate that.
Nice. I don't think we've even gone through 1.2, have we, y'all? Did we do 1.2 or am I crazy?
We did
No,
not do it.
we didn't.
Okay, so Mike, let's do the 1.2 and then section now, and then that will answer that question. If it doesn't, we'll answer it anyways. So let me go ahead. Oh,
I
you
was
said
just saying, sounds good.
nice. Okay, love it. All right, so let me get us open. If you have your textbooks, we're gonna go to the one that spot. Let's see. Okay. And I think we have a small enough group here today that maybe we just stay as a large group, and that's nice for people who watch recordings because they get to see the recording. So 1.2 is looking at, well, it starts with this concept of time management. And then we're going to use the things we learned from 1.1 about percentages, specifically relating them to pie charts and graphs. And after we do this, we're going to talk about the project that is your exam for Unit 1, because this leads right into the project. I think our author is most definitely correct. This was the most difficult thing for me when I was a young undergraduate. I went to college. High school was fairly straightforward for me. One of the nice things about high school is someone managed the time for you, right? You've got classes all day long, and maybe you have a study hall built in there, and they say, go here at this time and do this, and you don't have a whole lot of freedom. And then if you do the traditional college path like I did, you then go to college and they're just like, hey, do whatever you want and pick out what classes you want to do and good luck. And then they also give you access to internet and video games and tons of people. And like it's for some people, it's crazy. And I almost fell apart. It took me a couple weeks to figure out how to, manage my time and do homework and those kinds of things. So you all, I think it's maybe a much different experience at a community college because lots of students, you're working full time. Many of you have families. Like you're probably experts at time management. So what we're going to do is kind of take a look at how you manage your time and just see maybe is there a better way to do it. I don't know if you've ever done this. If you've heard of the book The 7 Habits of Highly Effective People, that's one guy's version of how to best manage your time. It's pretty hardcore. I read it and I'm like, oh, this is amazing. And then I'm like too laid back and unstructured of a person to live that life. I just couldn't do it, but I wanted to. It seemed awesome. So we're going to jump right to this. This is a sample time chart that a particular student, a made-up student, created. And I think it's kind of awful because they used letters for their different categories of time usage. So we have to go back up here to see that O stands for other time commitments, and S is sleep, and W is work, and H is homework, and C is class time. Why not just put the words in there? You know, presumably they typed it, but whatever. And notice that we've taken a week's worth of time. So here's the 7 days in a week. Why did I just write 7? And we've listed them out. So 1, 2, 3, 4, 5, 6, 7, whatever. And then we've broken them down into 1 hour increments. And started at 12 a.m. and ended at 12 a.m. again. I have, if anyone's a veteran here, you know that the military uses, is it military time? Is that the correct word for it? Where you go, I think, is it 0 to 20? Yeah, 0 to 24. And so there's no confusion of like which 12 a.m., like which 10 o'clock is this? Is it a.m. or p.m.? And which one is that? It's just, this is 1,300 hours right here. And 2 o'clock would be 1,400 hours. I've seen students who do this so in the project, you're going to create something like this, where you're going to write out the 7 days of the week. You're going to map out the 24 hours in that week. I encourage you to stick to 1 hour increments, but you could do half an hour increments. You could vary it if you want. And then you're just going to plan an idealized schedule. Like, this is what I want to do. Research suggests that 8 hours of sleep is optimal for you to live the longest. And that if you get more or less than that, you're actually cutting time off your life. That's always bad news for college students and parents, because you're like, oh, well, I sleep like 1 hour a week, so I guess I'm dying. Apparently, that's what the research says is happening. So you're gonna decide some categories of time usage. These are super vague. Like, sleep is probably a good one because that's a lot of time, and work is probably another good, like, big umbrella one. Class time is definitely a fixed one, especially if you're taking more classes than just this one. Those are pretty big chunks. Homework study time, that's potentially a big chunk, but then other is, like, to me, super ridiculous. I would break other down into, like, maybe screen time. Like, how often are you looking at your phone or your computer or the TV? And then maybe like meal times, like how much time do you spend creating meals and consuming them if you're the meal maker? Maybe another big usage of time is like personal care. So like brushing your teeth and showering and putting clothes on. Maybe that's not a big chunk of time. I don't know. The goal here is, in my opinion, is for you to create a schedule that is how you want to live and is realistic to what you want to do. I have no idea what your lives are like, so you can completely make it up. Don't worry, you're not cheating. I don't care. I'm more interested in the math behind it, but I designed this project to maybe be useful to you, to look at how is your time being used. Could you maybe make it a little better? Okay, so there's that. All right, so let's dive into the parts of this. The author says, count this. And that's what a robot is for. So I'm going to give you the answers to this. I just have to grab them real quick. No, I want to, yeah, that's the one I want. And then I'm going to turn you loose on the rest of the questions. And we'll I want to hear you all do it. So don't look at the other answers. Yeah, oops, wait. 1532, 54, 1552. Oh, I didn't memorize that. 1532. Was that 54? Was this 15? 1532, 54, 15. Okay. Got it. Nope, I'm wrong. Last one is 52. Okay, so take a second and try number 4. But let me make sure I see what the, oh, thank you, Jennifer. Look at you. You're faster than me. So number 4 says, without adding the hours in the table, how can you decide what the total number of hours should be? Right, so he's asking how many hours are in this, or how many hours are in this. So instead of like adding these all up, here's that little sigma notation, adding this, how could we figure that out?
24 times 7.
Oh, say that again.
24 times 7.
Why'd you say that?
There's 24 hours in a day and there's 7 days that we're doing.
Okay, love it. Y'all get that? 24 hours. Let me write the units on this because that's coming up pretty soon. The whole unit notation stuff. So there's 24 hours in one day, and there are 7 days in 1 week. Don't worry about these units yet. And so what we get here is the total number of hours in 1 week. 168 hours per week. That's all the time you get. By the way, time is a mental construct. Someone just said, let's say there's 24 hours in a day. It's related to like the moon, right? And the rotation of the earth and all that kind of mess. Or is it the orbit of the earth? I should know this, but I don't. At any rate, 168 hours in a week. Okay, how about this one? College advisors would tell you that a good rule of thumb is you should spend 2 hours studying. And study here could also mean homework. Those are kind of the same thing. Outside of class for each hour in class. By the way, how many hours do we spend in class in a week? Or how many hours are on the books that this class is like slated for? Anyone know?
3.
Close. It's a 4 credit hour class. So how many hours based on this should you be spending studying? If it was 3, go ahead.
I'm spending more than 4, but
Oh, good. Well, so in class, we're supposed to be meeting, like we have these sessions for 4 hours a week, except for this week because of Memorial Day. So then you're supposed to be spending 2 hours outside of that to like stay on track based on this, based on this mess. So to get a good grade in this class, supposedly, you should be spending 8 hours per week studying, plus the 4 hours per week in class, for a total of 12 hours per week just for this class to follow this guideline. And if you have any other classes, it's the same thing. Like if you're a full-time student, I think that's what, 12 credit hours? You're supposed to be spending 24 hours a week studying, plus the 12 hours per week in class. What is that? 36 hours a week doing school-related activities. Doesn't leave a whole lot of time to do other things in your week. Okay, so we want to check for our student. Talk me through, how are we going to figure out if they're following the advice? What do we need to do? Let me make sure I put it in the chat. Oh, okay. Jennifer says 15 times 2. All right, so they're in class for 15 hours a week. Our person says that they need to do 2 hours per week outside of class to get a good grade or pass or whatever the criteria is. So they should be spending 30 hours per week. Does that actually answer the question? What do y'all think? Have we answered? Is the student who filled out the table on page 22 following that advice? Okay, tricky, right? So that's why I said homework counts as study time. We're going to assume this is study time. And so our person is spending 32 hours per week studying. The recommended time is 30 hours per week. So our answer is yes, because 32 is greater than 30. How's that? Good. I had a professor, I was taking a math class, what was it? Differential equations. And this professor is tough. She was tough as nails. And I failed the first exam miserably. Like I was a pretty bad student. And I went to talk to her, and her first question was, how many hours did you spend studying for the exam? I was like 30 minutes or something. I don't know, it was like ridiculous. And she's like, you should be spending 10 to 15 hours studying for the exam. That's in addition to the 2 hours per week you're spending studying for the outside of class, plus I think it was a 4-credit class, plus the 4 hours in class. And like a young, ridiculous student, I dropped the class because I was like, oh, I'm not going to do that. I can't do that. I should have stuck with it, but I didn't. Okay. Now we get to the part from 1-1. So I'm going to copy these hours down again, and your job is to figure out what percentage of the week is this individual spending in each of these categories. So help me out, y'all. What do we need to do to calculate the percentage of the week spent in each of these categories? Maybe I should step back. What is our definition of percent? Not the divide by 100, but when we're calculating a percent, how did we define that? Did we do that in here, or was that my stats class? Oh, no worries. I want to make sure let me show you all where the book is again, because it's a little bit of a mess. And one problem with the book is if you haven't done the diagnostic test, it won't let you get to the book. So don't start it unless you have started it. The place where the book is at is when you log in, you click these little 3 parallel lines, and then textbook, and then ebook. And it should open up this this new window. Does that help?
Yeah, that helps.
Okay, good. Let's see. Okay, in case we have, I can't remember. I've got too many, I'm teaching too many classes to keep track of what I said and what. Did I tell you all this? It's the part divided by the whole.
Yes.
Oh, yay. Oh, I'm glad I said that. Okay, so anyone know the whole in this scenario?
$168.
Nailed it. That's the week. So what's the part?
The 15, 32, 54, 15, or 52.
Nailed it. Each one of these. So what you're doing is you're taking each of these parts and dividing it by 168. That's going to give you a decimal. You're then going to convert that decimal to a percent, and you're done. Remember how to convert to a percent, multiplied by 100. Now, I want to show you a trick. So if you have Excel, maybe I should do this in Excel, shouldn't I? Because you all have Excel. That's worth showing you that again. Let me not do this in Google Sheets. Let me do this in Excel. So you can log into your email account. And go to your apps. Okay, awesome. Thanks, Dennis. Okay, sorry, y'all. Oh boy, now you're see, I left all my emails up there. Okay, so remember when you get into your email account, you click the triple dots on the left side, and then there's the Excel document or the Excel app thing, and you want to open that. And we're going to open a blank worksheet. You can also do this in Google Sheets. I don't know why it's downloading. Wait for it. What is going on? Let's just try again. Well, okay, it's for whatever reason it's downloading something. So I'm just going to open it on my computer. And we'll go from there. Essentially the same thing. Now what we want to do is type in these numbers. No, not that one. 15, 32, 34, 15, and 52. I'm going to go ahead and put in the labels just so we can keep track of that, because then I'm going to show you how to create a pie chart and all the rest. And this might make your life a little bit easier. Okay. How's everyone doing? Are we all good so far?
Yep.
So I think it was you that said the whole is 168. I'm going to show you a trick. Well, I'm going to teach you how to like program in Excel. If you want to do a formula in Excel, you hit the equal button. And then what I want to do is add up all these numbers just to show you that. So I type the word sum and I put in parentheses. I select these, I select the cells. And so notice it says B1, the thing to B5. It's saying add up everything inside these cells. Hit enter, there's that 168. Now, what we wanted to do is calculate the part, so the 15 divided by the whole. So let's do that. We're going to do the equal button. Then I'm going to select the cell, and there's a particular reason why I want to do that. I'm going to hit the division button. So that's the like shift question mark, or if you have a number pad on your laptop, it's the button above 8. And then I'm just going to put in 168. When I hit enter, there is the decimal version of the percent. 0.089285714. Now, what's awesome about Excel is I want to do that for all of these. So I select that cell where the formula is. And then I put my cursor in the bottom right corner. It changes to that black plus sign, right? Click and drag. And it does that calculation for all the other columns all at once. And then it also like does the sum of all of them. So what it did is it took the next cell, here it was B1. When I dragged it down, it took B2 and it divided that cell by 168. And then when I dragged it down again, it took B3 and it divided it by 168. You can see those formulas populating in here where I drug it. So it's just like a fast way to get the calculation. One of the later projects, there's going to be like 195 or 95 numbers in Excel, and you're going to have to add them all up. So you're going to want to know how to do this. You start to use this Excel stuff. Of course, I'm going to show it to you each time, and hopefully it'll get you'll get good at it. I've heard out in the business world that having skills with like Excel and Word and all the rest is super desirable.
Mhm.
Now go ahead. No worries. We want percentages here. So one thing we could do is take each of these decimals and multiply them by 100. So notice again, I hit the equal button. I selected the cell, and then I put that asterisk thing in there. So that's the Shift 8 button, or the asterisk is above the 9 in the number pad. That's telling Excel multiply these two things together. There's our decimal. I mean, there's our percent.
Could you do that again, please?
Most definitely. I was about to ask that. Were you good with the decimal part?
Yes.
Okay. So we're repeating that, except this time, because I want to convert that decimal to a percent, I'm going to multiply that decimal number by 100. And the multiplication symbol or command or whatever is the asterisk. And then I type in the 100, hit enter, there's the percentage. Select the cell, and same thing as with here, you want to put your cursor so that I don't know if you can see that, there's a little like filled in square on the corner there. And put your cursor over it, it changes, and then you just drag it down, and it copies that formula for the rest of the cells. There's our percent. Now the author wanted these rounded to the nearest percentage. These have tons of decimals. So this button here adds or does the rounding for you. It adds decimal places or removes them. So I'm clicking this one, and notice it's rounding it to, there we go, the nearest percent. And there we have it. I need more coffee. Any questions? On the midterm, you will have access to Excel. I don't know that you will need it, to be honest with you. A calculator might be enough, like Desmos might be good enough, but there's some things that Excel does really well, like this. I don't know that we need to bother, but I will. So back on question 6, we now know that 9% of this student's week is spent in class. 19% of their week is spent doing homework. My goodness. 32% of their week is spent sleeping. 9% of course working, and then 31% doing other activities. It was a nice doggy. I think the dog was just saying hi. That's what I tell my girls anytime a dog is barking. They're just saying hi, but don't go over and touch them. Oh, he's hungry. Oh, give the poor boy some food. Or maybe he ate his breakfast and just likes food.
It's my neighbor's dog. He just wants a treat over here.
Oh, oh, do you give the dog treats?
Sometimes.
He's got you trained.
Yes.
Love it. Okay, here we are with another study. someone, it would be fun to talk about how the study was put together, but that's for unit 4. Someone did a study and found that most college students get 6.5 hours of sleep per night on average. Now, I believe this was probably a traditional college student, meaning someone who's going to school full time, fresh out of high school. Usually, community college, we have a pretty big mix of whether you're traditional or say non-traditional, as someone that's gone out and had some life experience and coming back, which I think is actually a really good idea, because you go to college and you have no idea what you want to do for the rest of your life, and you spend thousands of dollars getting your degree in like basket weaving, and you're like, I don't want to do this, and so then you have to go back. I don't know. Anyway, so 6.5 hours of sleep. But then they did another study and found that their academic achievement, meaning their grades, improved if they could average 8 hours of sleep per night. So our author says, hey, what % of hours in a week would be devoted to sleep if you get 6.5 hours of sleep? By the way, if you don't like fractions, like I'm not a big fan of this mixed number, 1/2 as a decimal is 0.5. Let's change that to 6.5 and be rid of that nasty 1/2. So there's 2 ways we can solve this one. For the sake of time, I think I'm just going to move us forward. We could say, well, what % of the day is spent sleeping? And that will get the same result as if we found out how many hours would you sleep per night divided by the 168. So we can just do this, and this will be the same percentage as if we did 6.5 times 7 and 24 times 7 for the 7 days in a week. So this is 27%. And notice I multiplied by 100. I didn't actually do it. I just did it in my head to get to 27%. And then 8 divided by 24, I'm pretty sure there's going to be 33%. Yeah, because that's 1/3 of the week. So we'll just round that to 33%. So if you're getting 8 hours, if you're averaging 8 hours of sleep per night, that means you're spending 33% of your week with your eyes closed, like asleep. And if you're averaging 6.5, you're spending 27%. Remember, this is how you live longer and function better, and like it lowers blood pressure and all this. I heard another study that some scientists said, from an evolutionary point of view, there is no reason for anyone to ever be awake. Because sleep is just so good for you. But if you slept all your life, that wouldn't be fun either, right? So how's our student doing? Well, let's look back at the % of their week that they're spent sleeping. They're spending 32% of their week asleep. And based on this data, they should be spending 33. So they're pretty close, right? They are close to the recommended. I don't do too well with this. I need to get more sleep. I know my life would be way better if I did. Okay, how we doing? Y'all feeling good about this so far? Part of your project is doing exactly this. You're going to create your categories. You're going to write up your idealized schedule. And then you're going to calculate the percentage. Oh, good. I'm glad I hear someone feeling better. And also good. And then now, Mike, we're getting to your question about the percentage. So the first thing we need to note is that a circle can be, that's a key word, can be divided into 360 equal units of measurement. Why? Because someone chose that. Degrees are a mental construct. They're totally made up. Someone looked at a circle and just said, oh, let's see, if we made the whole thing 360 degrees, then we would get nice numbers if we cut it into fourths. Because it'd go from 0 to 90 to 180 to 270 back to 360. And then if we cut it into eighths, we'd also get nice numbers. And like, so 360 is divisible by 9 and by 8 and all these different things. So it's just a nice number. So we picked it and there it is. There's another measurement that's more related to reality. They're called radians, and they use, their units are pi, like the number pi, which is used in the calculation of circumference and area and all the rest. So this radian has a little more meaning. It's not quite as made up as the degree, but whatever. So the key thing here you need to know is the entire circle has 360 degrees in it. And what we can do is we can take our information. Did I lose it? Here it is. We can take this data and create a pie chart based off of these percentages. And when we create that pie chart, we're going to get what's called sectors. So this sometimes sector here for like people who wash their hands after using a public restaurant, it has a certain measure of degrees, and that measurement is right here. That's a particular amount of degrees. And since this is 29% of the responses, the number of degrees is 0.29 times 360. So the percents in the pie graph are also related to the degrees that make up the sector. So that sector measures exactly 104.4 degrees. By the way, that little circle like up there, that's the degree symbol. Okay, so how does that relate to our friend here? Well, we can calculate the degrees back in Excel. We now just take the percent, these decimal versions, and multiply that value by 360, and we get the degree. So back in Excel, I'm hitting the equal button. I'm selecting the cell that has the decimal version of the percent. I'm doing the asterisk button for multiplication, and then I'm typing in the 360. And here's the number of degrees that each of these sectors would take up in a pie chart. Let me pause there and make sure you all are good. Which connected to Mike's question. Wait, let me find, no, that's not the right. Where are the worksheets? Let me find the worksheets while you all are deciding whether or not you want to ask me a question. What I have shown you here in Excel is how I would encourage you to do this 1-2 worksheet. So I went to this website, the CBP, what is that? Customs and Border Patrol website from the government back in 2020. And I took the data. These are the number of children, unaccompanied children, and children are defined as a human aged 0 to 17. Unaccompanied, I believe, means there is no adult, so someone over the age of 17 with this child. These are the number of children that were apprehended at the border, at the US Southwest border. And the Southwest border, if you didn't know this, I didn't know this until I looked this up, is broken into these different regions. So this is how many children showed up at these regions, and Border Patrol agents encountered them and like filled out paperwork on them. I notice I gave you the total, and your job is to create what percent of unaccompanied children were encountered at Big Bend. And then how many degrees would that make up in a pie chart? And then what percent are in Del Rio? So what you want to do is you can select all this. So I selected it, and then I right click and I click copy. And then I'm going to go over to Excel, And I'm gonna right click again and paste, and there's all the numbers. Now, if you want the words to go with it, you can do that too. Notice I'm like increasing the font so you can actually see what's going on and whatever. And then you can do your percent thing and your degrees thing, and you can save yourself a ton of time by calculating it here instead of doing it by hand in your calculator, one item at a time. Does that seem okay for y'all?
Yes, would you mind doing a couple of those just to show us how to do it in Excel again?
Yeah, definitely, definitely. Let's see, I'm going to just copy this whole thing over. So I selected that corner and then I went over to Excel and let me just delete all this mess. And then I'm gonna paste it. There it is. Okay, I just copied the whole table and now it's in there. So remember, the percent is equal to the sector or the amount, the part divided by the total, which in this case is the 189.96. So there's the decimal version of the percent. Now I'm going to show you another button that I'm not a big fan of, but it's okay that you use it in Excel. Excel has this nice percent button. Since we want this to become a percent, I can just click that percent and there it is. And you might be upset that I made you do all of this mess over here. We're multiplying, but I wanted you to see the multiplication stuff in this little change the decimal things. So there's the first one. And then remember, you just go to that bottom right corner and you drag and it gives you all the rest. Oops, it disappeared. Sorry, I don't know what happened. How are we feeling on that? Does everyone seem okay?
Can you do that one more time?
Which part? The whole thing?
Yeah.
Definitely. Let's do the whole thing. Yep, not a problem. I know it's hard to, like, if you're trying to do it on your screen plus watch me do it, like, it's crazy. So what we're doing is we're telling Excel, here comes a formula. So we're hitting the equals button. And that's the thing that says, here's the formula. And then I'm using the mouse to click the cell that contains the numbers. And then since a percent is the part, which that's what the 254 is, divided by the whole, that's the sum of all these, which is the 18,096. I want to divide this by the 18,096. Hit enter, and there is your decimal. Now, hang on, let me clear the formatting so that it. Okay, so that's the decimal version when we do that. Let me do it one more time. So equals, select the cell, divide by the total. Hit enter, there's the decimal. And then you can drag it to get all of them, but I don't want to give away the answers yet. You just pause the recording and you'll see the answers. When I say drag, I mean take your cursor and put it over that bottom right corner so it changes symbols to this, and then hold and drag and you've got it. And then if you don't want to have to do the multiply by 100 mess, you can just use this percent button. And what it does is it multiplies the number by 100 and then slaps a percent symbol in there. So it's kind of nice that it does that.
Thank you.
You are welcome. And then, so then for degrees, we do the same thing, right? We do the equal sign, we select a percent, except this time we're multiplying that percent times 360. Now, this is where things can get a little messy and it could mess you up later in life. Excel knows that 1% is 0.01. In fact, it knows it's 0.01, whatever it was, all the decimals. And so when I do C2 times 360, it's not doing 1 times 360. which is 360. It's doing 0.01, whatever times it, and it's getting this, this many degrees. So that little sector in the pie chart will be 5 degrees. And if I just want to round that to the nearest degree, I would move this, click this button that's rounding. If I wanted to include a few decimals, there we go. There's 2, here's 1. Notice Excel is doing the rounding for you. That 5 added 1 to the 0, which is why it's 5.1. And then because 0.1 is less than 5, the 5 just stays 5. And same thing here, drag it down and you've got all of them. Oops, except that we didn't do these. Okay, there we go. How are we doing? Anyone stuck on that? Like anyone need help doing any piece of this?
I feel kind of embarrassed to ask.
No, don't be embarrassed.
So at the very beginning, when you were transferring everything over, so you wouldn't have to enter it in manually, how did you do that?
Great question. I didn't know it was going to work. I just took a chance. See this like square thing in the corner, the little that?
Mhm.
I clicked that and it selects the table. And then I used the keyboard shortcut Control C. That's for a PC. If you have a Mac, it would be Command C, or you can right click and do copy. And so it's
Okay.
copied that table. And then in Excel, what I did is I clicked this plus sign down at the bottom to create a new sheet. I thought I did. There we go. And then you can either right click and do paste, or you can do Control V. Oops. And there it is.
Okay.
And then because it's so small, I did this. I made this font bigger. And then if you double click in between, it spaces it out so the words are all in there nice and neat. And then ran through the stuff. Really good question, because that saves lots of typing time.
It's not letting me do it.
Oh,
It's like all one big line.
you know why it's because, do you have the Word document?
It's a PDF.
That's why. It's because it's the PDF. Ugh. Okay. Let me see. Did I upload the Word document? See,
It's okay. I don't mind typing it manually. That's not an
Okay.
issue.
I can upload the Word version of it. Did I? No, that's it. If you want. It's probably faster to just type it by the time I get it up there, but
Yeah.
I'm going to put it up there because I'm sure there's going to be someone watching the videos that might like it, and to save myself some time.
Thank you.
And you time. Yeah, you are welcome. But I have to remember how to do this. What's going on here? Files, yes. Oh, there was an upload button. Duh, it's big right there. I should have done this because so many people are trying to do things digitally, and the PDF isn't working as well for them. And I've been emailing out, this file to everyone, and I could have just uploaded it. Okay, so now it's in the I3 class. Let me go to the I4 class. So the next thing we're going to do is create the pie chart. And I would hate for you to draw it. Excel does it perfectly and quickly. Sheets does the same thing, by the way. So if you have a Mac the numbers software also does the same thing. Oh, I bet I didn't publish that last thing I uploaded. Okay. Wait. I didn't put the right thing in here, of course. Here we go. Okay, it's finally there. So let me go back to, actually, we'll just do it on this one. No, let me go back to this one because I want you to see a couple things. So in the textbook, the author says, all right, let's build a pie chart using the information of the degrees. And like, oh, that's cool. It's nice that we're thinking about how this pie chart works and the degrees in a circle. But boy, this is a weird way to do it. Like we typically put 0 here instead of 90 here. So I really, it's like, yuck, don't look at that. What you do is you select, if you want the names in there, you select the names of the stuff and then the hours. We don't need to select the percents or the degrees. That's just for our own understanding. And you go to Insert, which is on that top ribbon up there. It's next to Home. And there's a pie chart little thing under, what is this? Charts. So if you just click that, you can see there's a bunch of different options. 3D pie charts shouldn't really be used, honestly. They can be misleading. And here's your nice pie chart. Now this is a pretty terrible one if you look at it. Like, where are the percents? Those should be labeled. You have to manually include the title. Weekly hour usage, I don't know. We'll label it that. So if to add those other percents, there's a couple of things you can do. One of the fast ones is you can do a quick layout and you can pick the one you like the most. Why is it not showing up? There, that shows percents in there. Notice the quick layout is up here. You could do like that. There we go. Now it's showing the different pieces. Maybe you like the home block. Who wrote that? A good chart should clearly label the categories and the percentages. So if it doesn't have numbers, it's kind of a garbage chart. And there you've done it. You got it. Anyone need to see that again? Okay. So for this one, so you don't actually need the degrees for your homework assignment. You can just do this and then insert and pie chart, and there they are. Again, I don't like that particular one. That one's not great either. There's a lot in this one, so it makes it harder to see everything. I kind of like that one. You can make your chart a little bigger. That might be helpful. Notice this one doesn't actually have the percentages. It's putting in the numbers instead of the percent. So let's see, where's this? There's the percentages. What the? Whatever. This one's okay, I guess. But that font size should be a little bigger so we can actually see what's going on here. The reason they made it small is because to fit it all in. You can't even read that one. Okay, questions, concerns, comments? Sorry, that's stats. Let me get to. So if you are doing this in Word, here where it says upload the file, link to Canvas, or paste your graph here. If you're doing this in like a Word thing, you can right click this graph and do copy, and then you can just paste it right here. Yikes, it's enormous. And there it would be as part of your homework. Otherwise, you can save this graph, like you could save all this and submit your Excel file. And I just need to add that to us so you can submit like that for the assignments. Notice the second page, I give you a pie graph, and then I ask you some questions about it. So how about you all see if you can't do letter A for question for the worksheet 1.2. See if you can't answer that question. Let me get rid of this because it's ruining my formatting. And you will see if you can't figure out how to answer that one. Oh, I love it. You all that said that, how did you get the 2096 or whatever that number is? Nice, you all are crushing it. How'd you do that? Oh, okay, Jennifer, love it. So we're looking at Rio Grande, right? Is that how you say it? It's 44%. So we convert that to a decimal, which is 0.44. We multiply that times the total, 47,642. By the way, has anyone looked at this context? In 2021, there were 47,000 minors or children that showed up at the border. And back in 2020, there were 18,096 during this time period. So like a huge jump. It was all over the news. Now, we should talk about this number a little bit. Like, what are the units on this number? Oh, I have number left. I can't. It's true that 0. Okay, children, yes. So when we round, what makes the most sense?
Rounding up.
Interesting thought. Rounding down. Sorry, okay. I gotta get the right number here first. So anytime we do this, what you should round appropriately, meaning if it's 5 or greater, add 1. If it's below 5, get rid of it, which means that, and then in this case, we should not round to the nearest decimal. So we shouldn't round to here or to here because it's children. You can't have part of a child. So we should round this to 2262. And I need to change this approximate symbol because this is exactly 2262.48. And then when we round it, that's approximately this many, and then you should have your label on there, children.
It should be 2962.
Ew. Yes, thank you.
All right.
It's a struggle here, over here. Okay, there we go. Good. Does everyone feel good about that? So, I want to be careful with the language that you all are putting in the chat. The word round down is a specific thing in math, and round up is also a specific thing in math. So round up would be make this 2963.
Can I ask a question about that?
Please, yeah.
So when we're rounding, do we have to take into account what we are rounding? Because my assumption is you just round up because you can't have a percentage of a person. You would automatically have another person.
Right, because you're thinking, yes, if right, there isn't part of a number. So what do we do with this? So that actually it ties in directly to this question here. Notice the actual number was 2964. So why is there a 2-child difference between the two? And what you need to do is think about, where did this percent come from? This 44%. And to help with that, let's go back to this problem. And let me get rid of this decimal thing. And let me show you something. So the decimal here is 0.014036251, right? Now, if I took the total 18,096 and I multiplied it by the decimal version of this rounded to the nearest percent, meaning this 1%, check out the number I get. 181 is what I would round that to. That is way off to the 254, right? That's a really big difference. Why is that happening? Like, what caused that difference between the actual number and the number we calculated using the percent from the pie graph? And then we'll answer your question, Maya.
What was the question again?
So why is it that when I take the 1% from the pie graph, which is what I did right here, and do 0.01 times the 18,096 and get 180.96 children, or 181 children, why is this number so different than the actual number that were apprehended at, or encountered at Big Bend? There might be a better way to help you all see this. So there were 18,096 times 0.01. So there's 1% of 18,096. And then 18,096 times, what was it? Then we did 254 divided by 18,096, and we got this. And so then if we did that times 18,096, we get the 254, right? Do you all see what's happening? Or am I just being super confusing? Because that's possible too. I always think everything I say is completely clear, but it's typically not. So let me try to help. This 44%. Oh, wait. Oh, someone said something. Oh, yes. When were the office hours? 8:30 to 11, Monday through Thursday. Right. So this 44% is a rounded percentage. It's actually rounded to the nearest 10th of a percent. Yeah, so nailed it, Jennifer. That's what I'm trying to get at. Like when we take the problem we worked on before and we calculate the percent, so we do the part to the whole. So we took this this 254 children that were apprehended at the Big Bend area and divided by the total children apprehended in all the regions, we get 0.0140362511052. Well, then when we create the percent and round to the nearest percentage, we get 1%. So then if we use that 1% to calculate, well, based on the 1%, how many children were apprehended at Big Bend, we would get the answer of 181 children. Well, that 1% is a rounded value, and the rounding we did made a huge difference. That's what happened back here on this worksheet. This 44% is a rounded value. It didn't make a huge difference. It's only 2 children different, but it's a whole 2 children difference. So Maya, going back to your question, should we always round up if it's people, or should we do the appropriate rounding if it's like money or whatever? When you round, you should always round following the standard rules of rounding unless specified otherwise. So rounding up is a specific type of rounding, and it's where you add 1 to the number no matter what the decimal is. For this class, you're never going to be asked to do that. I'm always just going to say, write the answer. And then when I say this, make sure your number makes sense. That's getting at what you were saying, Maya, that, hey, we can't have part of a child. So to round it correctly, since this is the 0.4 is less than 5, we would just drop that and this becomes our number. We weren't going to get the exact correct number no matter what we did, because this number here is a rounded percentage. That's why here I'm going to step out on a limb. Like in election years, when you hear someone wins by 1%, they win the vote or they won the election by 1%, that might seem like a really tiny amount. But if you calculate, let's say there's 300 million people that voted, that person won by 3 million votes. That's a ton of people voting for that person relative to everyone that voted. That's only 1%. So what I'm trying to get you to think about here in question B, and just in general, is that when we work with percentages, rounding percentages can have really big effects on things. So we have to be careful. Is that getting any better, or am I just talking crazy nonsense? Which is totally possible too. Okay, thank you, Jennifer. How about anyone else? Hopefully it's a little better. Okay, there's another type of chart. It's called a bar graph, and it's a way to compare the sizes of different values. So pie charts are only useful when you're comparing parts to wholes, to a whole, because everything has to add up to 100%. Bar graphs are great when you're comparing things that like parts of parts or parts to other parts, because they don't necessarily add up to 100%. Now we can use a bar chart in this one, and it gives us the exact same information as the pie chart. I just go to insert and then bar chart, and there it is. Man, that's tiny font. But this isn't really any different than the pie chart in terms of the information. If we look at this problem, this is a telephone poll conducted back in October 2016. So not too far away from the 2016 election. And people were asked two questions: who are you planning to vote for? There were 4 candidates back then. So Clinton, Trump, Johnson, Stein. I don't know if anyone remembers those names. And then maybe you hadn't made up your mind yet who you're going to vote for. And then the second question was, for these candidates, who do you think is qualified to be president? So if you think about those two questions, you can only pick one person to vote for. Right, you can't pick 2 or whatever. We don't. The national elections aren't ranked choice, where you say, this is my first choice, here's my second, here's my third choice. I think Alaska is one state that does a ranked choice election, and it's actually a pretty good election method. You don't have to do recounts as much, because you just there's a whole thing we don't talk about in this class, but it'd be fun too. Now, when you talk about qualified, someone could think that all 4 people are qualified. So one person could show up in each one of these bars. Right, so these bars are definitely not going to add up to 100%. It's going to be more than 100%, because I, as a person, might count in all 4 places, or I might count in 2 places, or whatever. Whereas over here, my choice it only represents one person's choice. Does that make sense? The difference between the two? So I think we're done with 1, 2. Let's make sure everyone knows what the lesson check is for 1, 2. So it says, enter the answer to question 6 on page 23. What is the percentage of hours spent on homework? Notice it says round to the nearest percent. So if I go back to where we did stuff, the answer is right here. I think it said homework, right? So this is lesson check 1, 2. putting in 19%. Perfect, thank you. So 19. I don't know what happens when I submit the quiz. Oh, it tells you the score, but it doesn't show you the answer. Good for me for doing that. Okay, we're gonna look at 1-3 really quickly because it's a fairly short section. And there's really only two things I want you to learn to pull out from 1-3. So I know we only got like 25 minutes, but that's about all the time we need. Does anyone have any, is everyone doing okay? I want to make sure you're feeling like you are understanding. Oops, wrong one. Okay, good. Okay, so 1-3. Yes, you can resubmit lesson checks. Yep. I think you all let me, if I wanted to make it so you could resubmit them. And I thought I did that like Monday night. If it doesn't let you resubmit, let me know. And I'll go back in there and fix it. And I think you can do that up until the due date's done. What? What's going on here? Here we go. Oh, well, okay. Let's see if I can fix that right now. Well, it should. It's set to do it. Let's see. Let me go to student view. Something's not found. Oh, maybe I was in the wrong class. Maybe I only did it in one class. Let me double check.
I think I was actually on the wrong screen, so I think I got it now.
Okay. Oh, good. Okay, good. Okay, so 1-3. Here we go. 1-3 is we got this idea of like, hey, what do we need to do? A systematic problem-solving procedure, which I like. We're going to demonstrate that for one thing. And then how do we make guesses? And then I'm not worried about inequality symbols. So I want to jump to this page. I don't know which page this is in your textbook. This is the 1-3. This is a graph of an isotherm, and it connects locations with the temperatures. And then you can see the temperature. Perfect. Page 46. You can see the temperature across a wide variety of things. And this is one of the things that's a very important skill, in my opinion, because you're going to encounter this in the world a lot, I think. And that is like, what is the number for Las Vegas? Like, what is this value? And if you look at the graph, it doesn't give you a number for L. So you have to be able to read it based on the chart. So what do you all say? What's the temperature in Las Vegas in this particular, maybe this is a day, I don't know.
$40 degrees.
And how did you get that? I totally agree with you, by the way.
You just drag the line over.
That's
degree.
it. Yeah, if you look at L is like right on this line. So you follow it down and you're like, oh, everything on this line or close to it is 40. Nailed it. So another crazy thing about this graph is it's backwards from how we think of the y-axis. Notice positive, like the numbers are increasing as we go this direction, and they're decreasing as we go this direction. If you think about the world, that makes total sense, because the further north you go, the closer you get to like the North Pole, right? And the further south you go, if you're starting in America, the closer you're getting to the equator, which is the hottest. So in terms of the real world, it makes sense. In terms of a math world, we don't write numbers this way. It's smallest at the bottom, hottest or largest at the top. So what do y'all think about P? What's your guess for the temperature in Phoenix? Oh, look at that. I don't know how to use that. Let's get rid of that. So let me help you. I know you probably don't want to answer, because then I'm going to say, how'd you get that? And you don't want to have to say that. So if I draw a vertical line here, this is supposed to help me note that the top of this line is 40 and the bottom of this line is 50 based on these, right? And so then if I wanted to get like halfway between it, that would be 45. And then if I go halfway between 45 and 50, that's probably like 47.5. So my guess for this temperature is 47.5 degrees. Oh, look, you all blowing up the chat. Yeah, 45-ish. I would say probably a little bigger than 45, because it's a little closer to 50 than it is to 40. But that's it, the skill of guessing that. If you said it was 43, we'd need to talk about how you were reading that graph. Check out D, Texas. Same idea here. How you're wanting to visualize this is there's a vertical line in between. The top of the line is 20, the bottom of the line is 30. To me, that's exact halfway, which would make it 25. Oh, I should watch the chats and let you all say it. Yeah, nice, Jennifer. We totally agree. Springfield, same idea. Again, we're thinking of this vertical line here. 10 degrees here and 0 degrees at the top. It's closer to 10 than 0. I don't think it's halfway. I'll agree with that, Jennifer. That feels like a solid 8 degrees. Georgia, here we go. That's letter A. Pretty close to 30. Again, maybe halfway is here-ish. So yeah, I was thinking 32 as well, or 33, or 31.8, whatever you want to say there. Miami, this one we don't have a line, right? And we don't know what the line is below it. So this one's really hard to answer. Because what if the line is like this? Then you might say 55. But I don't know. Let's just say like 51 or 52. Since we don't know the next line, this one really can't be answered very well. And then New York is a tricky one. Sometimes negative numbers can mess with people. Notice we're closer to 0 than -10. So maybe -1.5 degrees, -2 degrees. Yeah. Oh, Mike, I like that. Yes. Miami it's greater than 50. That's a great way to say we don't know, because we don't know the next line, but we do know it's larger than 50 degrees. Excellent. Yeah, I like that thinking. Just while we're here, this is the 1-3 lesson check answer. I picked the 40 degrees because I think that's one that everyone would agree on. Lesson check 1.3. So let's, we're kind of going all over the place. I'm sorry, but let's jump to the 1-3 worksheet. So I Googled this because I thought it was interesting. I don't know if you remember the 2020 election. One of the questions in Michigan on the ballot is whether or not we would legalize cannabis for recreational use, or marijuana for recreational use. And if I've talked about this in this class, please tell me to be quiet. And of course it passed, as everyone knows, and then Michigan came up with laws about how could you get a license and open up a store. And then I don't know if you've noticed, there's like a store on every corner, like a dispensary is what they're called. Of course, prior to this 2020 election, medical marijuana was legal, and there was a couple places in Jackson that I know of that had it. But then after that, I mean, it's everywhere. The little town of Hudson that has like, I don't know, under 1,000 people, maybe. I don't know how many people live there. I used to live there. It's got like 4 dispensaries within, really near it. That's probably because they're close to Ohio, and Ohio has not legalized marijuana for recreational use. Anyways, I went to this website and it listed out the number of dispensaries by state. Notice I've told you the total number of dispensaries in this pie chart. And then I gave you a terrible pie chart, right? Because there's no numbers. Plus I spelled Oregon wrong, which really bothers me, but I can't fix it. And so your job is to estimate the percentages for each sector of the pie chart based on what we just learned in 1-2 about how a pie chart is put together and what these percentages look like. Does it surprise you, by the way, that Oklahoma has the majority of dispensaries, more than any other state? I would have thought California, because it's such a huge state, but not so much. This one, when I looked up the data, I had data for all 50 states. I believe there were some states where marijuana is completely illegal for all things, I think. So not medical or anywhere. So there are, in here, there's some states that have like no dispensaries, or some other states that have like 1 or 2. So I lumped them all together because it would have been far too many slices for you to even be able to read. So you're going to estimate those percentages, and then you're going to ask yourself, hey, what should they add up to? Or you're going to add up your estimates and then think about what should they add to, and some more basic questions about understanding the pie chart. Then you're going to do a little calculation. And then I already told you this answer, didn't I? So the second thing on this worksheet is this idea of putting together how to solve a particular problem. And I want to do one from the book here. And if you all had questions on the other stuff, I would love to answer them. So it's this question from the textbook. How much would you spend in a, nope, not that one. Hang on, next one. Nope. How much money are you completely wasting every time you skip a college class? What information would you need to calculate this exactly? So of course I want to do this because I want to be like, see, you should come to class. And then everyone should be like, this is an internet class. I'm taking it as an internet class because I don't have time to come at a specific time. And I'd be like, yes, you are so right. That's why we record and I have office hours. So no, this is not why I picked this question. I like this question though. The first thing I want to note is as humans, we have a problem, and that is we are all biased. Like it's inescapable. It's impossible to be an unbiased human, right? Because we are products of the places we were born, the people we were born to, like how our parents thought, how our friends thought, what our teachers told us. It's impossible to be completely unbiased. It's good to try, but you can't. So what I want you to, what I'm interested in is how is this question, just how this question is asked, full of bias? Like what in here what is the bias? Can you all point to it? Or type out what it is, or mic out. What's the bias in this sentence?
They're assuming you're wasting time if you're not in class.
Yeah. Okay. This word, I mean, it's heavy bias. Like this guy is like angry. He's like completely wasting. Right. So that's biased. Yeah. I like what you said, Jennifer, that if you're not in class, then you're wasting your time because you should be there. What does it assume about class time?
It assumes that class time should be your main priority, because class time doesn't pay the bills at all, but
Right?
Or that there's valuable content in class.
Oh, that's the
Yeah.
bigger one, right? Oh, I am just such a great instructor and my class times are just so perfect. It is so valuable. You have to come to class in order to pass class. We all think that, instructors. So if you're finding class time is wasteful, like what I'm doing isn't helpful, please let me know. I am biased in that way. I do think that what I plan to do in class and what we do in class is useful for you and will help you pass. And I'm not like planning to do terrible things, but it could be awful. And maybe there's something I could do that would be better. I'd love to hear that. And those of you that can't attend and are watching the videos, if there's something you would like to see done in the videos, I would love to accommodate that. That's why I'm here, right? My job is to help you pass, help you learn the material, get through, get the grades you want, and get to the paycheck, right? This author, I have to call this out on him because it is biased and he's probably wrong. I've taken tons of classes where like I could have just read the book and done the work myself. I didn't need to sit here and listen to your stories. So I need to stop telling stories. I'm going to fix this problem. I'm going to change this question. He could have asked it in a different way that's completely unbiased. And that would be, what is the cost to attend class? What is the cost of one class? Right? Because you paid to be here. The only reason you can sit here and watch this crazy haired man talk is because of the tuition dollars you gave to college. No one else is allowed in here. So what did you pay to be here? What was that cost? Kind of an open-ended question, and I don't have the answers for you, right? So what would we need to know?
You would need to know how much you paid in total and the number of hours you are in the class total.
Love it. Okay. Total paid for class. What else? Total hours. Is that it? Is that all we need? We're quickly running out of time here. Or we could, instead of this one, we could do just the total number of classes. So we could do it by class sessions versus hours. Love it. How would we use that information to solve the problem or to answer the question? What is happening with that pen?
You could calculate the total cost of the class versus how much time that you missed of the class and the price difference of that.
So tell me the arithmetic or how would we do that? I agree with you. Yes.
So you would have to break down the class like per session, if you're doing it per session, and how much a session cost.
You
And
said
then
a very
how
special
many,
word.
how much time of the session that you missed, or how many sessions total you missed.
Love it. So we could calculate in terms of minutes and hours or seconds if we wanted to, in terms of just like literal amounts of time, or we could calculate based on sessions. And you said a special word that's per. Does everyone know in the math world, what does per mean? What operation does it mean? Arithmetic operation. I'm just going to say it because we're running out of time. Divide. So what we would do is take what we paid and divide by whatever we wanted, number of sessions, total hours, whatever. Does everyone know how to find out how much you paid for this class? And if you say financial aid, we're going to calculate in Unit 3 the cost of interest being added to that financial aid. So, of course, I have high school students too that say nothing because our tax dollars pay for them to go to class, which is great. There's students that are graduating from high school with an associate's degree, which is amazing. We calculated this yesterday in my in-person class. There's a place you can look it up. You can look on your bill, click under financial aid, and it itemizes out how much you paid for each thing. I forget the exact number, but it was including the textbook and the Alex Access. I think it was somewhere around like $764, seems to ring a bell. And then we are a 15-week semester, and we meet 2 times a week, with the exception of this week and like a week in Thanksgiving. So that's 30 class sessions. And so if we divide this, we'll get the cost per session. And the number was a little less because I remember it being $22. So this $764 might be a little high, but it's approximately $25.47 per session. How's that make you feel? Was it worth it? I also know, by the way, that you all are forced to take this class, that if you were given the choice, you might prefer not to take a math class and still get a degree. And you don't have that choice because of the general education requirements. So I'm aware of that too. But we are quickly out of time here. Your worksheet that you're working on is a similar question, except that it's how much do you spend in a year on gas? Estimate the amount of money you spend on gas in 1 year. Now, what I want you to do is write out the assumptions you make / the information you need. So what I mean there is, well, I want you to think about that. I'm looking for words. You're writing sentences here. And then for B, you're making up some numbers based off of what your assumptions were. So you might need the price of gas, and you're doing it for a whole year. So you have to think, how are you going to pick that number? Because back in January and February, it was $1 something, right? Or 2 something. And then in March, it was like 465 or some crazy number like that. Yes, this video is going to be uploaded. It'll be later tonight. I got to go pick up my girls from school. They're the pickup line has started. But yes, this will be uploaded. So I'm looking for some written words here, and then down here some calculations, and eventually you should have a number for me that's like, I don't know, $5,000, whatever it is. So does anyone have any questions for me?
Do you want us to gather information from like a website to get some of that
If you want
and
to
source
be more
it?
accurate, you can. You don't have
you
to.
need it?
On this one, you can just make it up.
Okay.
They're in the projects where I'm going to grade you. You do have to like give me sources and say, here's the car I want to buy, and here's the price of the car, and here's the website where I got it. But for this one, where you're just kind of thinking through stuff, you don't need sources.
I have a question.
Yeah.
It says that 1.4 is done. we didn't cover that today, or is due on the 11th. We didn't cover that today, so is that still gonna be due Sunday? Or
Absolutely not. Yeah, I need to move that to next Sunday
Okay.
because we didn't get through 1.4. And 1.4 is a kind of a beefy section, so we need to, I want to make sure we spend some time. Yes, I will change that.
Okay,
And if I
Thank you.
forget, oh, I can change it right here. There we go. Great question. Other questions y'all have? If you don't have questions, feel free to take off. Have a great weekend. You know, we can be in touch by email. You can show up tomorrow to my virtual office hours or in person from 8:30 to 11. If you need help or want to talk about anything, awesome. I'm here for that. Please, hopefully you feel comfortable reaching out to get help.
I have one last question.
Yeah.
The old homework that was not this 1.2 or like the one prior, could we go over that in class time, or should I just do that in the tutor hours?
You're talking like the 1.1?
Yeah.
We can do it in class time, except that there's not a class time between now and the next due date, which doesn't particularly matter, but it might be better for that one to do it in like a tutoring hours.
Okay, sounds good.
If it's really important to you to get it on the exact deadline, let's say that. I don't know why I'm still sharing my screen, but oh, I didn't change the worksheet. I'll change all those due dates, I promise. Anything else y'all need? Go ahead,
Eric,
Michael.
is there a way that you can share the lessons, like the links to the lessons, for every class time? Because it's almost easier to click on those than to flip
This
back and
thing?
forth through the, than to flip
Yeah.
back and forth through the book.
What I will do is make a module in here that just says unit lessons, and I'll upload all of them.
Thank you so much.
You're welcome. Mike, I would stick around and help you with 1.1 if I didn't have to go pick up my girls.
Oh, no problem. I was just wondering the best way to go about it.
Yeah, that's a perfect way. And I can't come early. Yeah, so if you want to show up tomorrow at 8:30, otherwise we can just schedule something at a different time too, if that 8:30 11 doesn't work.